Greetings and wishes. Welcome to the third lecture series on Explainable AI. In the past video lecture, we have demonstrated about what is the need of Explainable AI, what is meant by line, what is meant by shape. Like that, we have demonstrated in a elaborate manner. But in this class, we are going to tell apart from this lime and shape, we are having one more concept that is anchors. The anchors are nothing but high precision rule based explanation. That is, the word high precision is added. That means anchors ensures high precisions in explaining the results. So how it is different from this lime and shape? What is its contribution towards ensuring the precision in their decision making principles, and how it is going to explain the results in a very trustworthy manner? That are all we are going to see in this lecture series. So this is nothing but just a recap of lime and shape, so that you can also understand what are all the different things happened in the previous class, and what are the new things you are going to learn in this lecture series, and what make this topic more impactful in making the explainability more impactful, how it makes the decision making things more precise and trustworthy. These are all the things we are going to explain in this video lecture. Actually, what we are going to do is, first I will explain completely about the theory, and after that I will explain you the workouts, so that you can able to understand in a very easy and simplified manner. This is what we are going to do today. So the topic of interest is anchors, that is high precision rule based explanation. How this rule based explanation means what is meant by anchors. These are all the things we are going to learn new in this video series. So just I am going to recap. Previous topic is shape. So if you want to learn more means, please visit my video on shape, so that you can get better explanation and more impacts. Now, in order to recap, I am going to explain what is meant by shape in a one line manner. We are considering the features instead of instances, and all the features are considered suitably, and based on the shape values generated based on the training and its weight gained by the ML models, we are going to find who is the best contributor in attaining the final prediction value. So out of 100 features, which feature is going to contribute? How the 100 features are going to contribute in attaining the final score? This is more or less equivalent to a game. 100 players are playing a game means how each and every player will contribute in making the winning rate of the team. In that manner, this game theory is designed, and that value, in that manner only the shape principle is working. How each and every features are contributing to make the final prediction equivalent to the prescribed value. This is what the shape concept. Now what I am going to do is, slowly I am going down. Now we are going to take a new concept called anchor. What is mean by anchor? How it is different from the previously learned concept line? Local interpretable, model agnostic, explainable technique. Here also model agnostic explainable technique is coming. Local also coming. So more or less anchor and lime are same. So what we are doing is, first to learn what is mean by anchor. So anchor is also a method similar to that of lime, but in addition to the normal lime working, we are going to add some rules in along with the lime model. So if a lime model follows some condition, then it becomes a anchor. So in short, if I add if then condition, if this condition is satisfied, then prediction is this. If this condition is satisfied, then prediction will be like this. If I add the lime model, if it obeys certain condition, then that is called as a anchor high precision rule based explanation. That is called. So here this if then rules are generally called as anchors. We are calling. So in the condition we are mentioning as condition now in explainable AI, the same thing we are calling it as anchors. If a particular condition is satisfied means that is called anchoring of the predictions. We are holding the prediction to better instance. That is what we are having here. Also we have written that if then conditions are satisfied, that rules are satisfied, that means the prediction value will be with high precision. We are holding the prediction value with high precision around that instance. What are the instances we are creating? For that we are ensuring the high precision in predicting a particular value. So this was introduced by Marco Tullio Rubio and Samir Singh and Carlos Gestrin. So these are the contributors who make these anchors to better instant. So they just improved the Lime model by adding a small instance called if-then rules, so that the entire concept will become a new thing called anchors. This is a very simple concept, but really a good contribution. How this model become a high impactful model, how this precision is possible, on what basis these anchors are high precise other than Lime. These all things we are going to discuss in a step-by-step manner. So anchors provide rule-based high confidence explanation. Okay, so this is the one-word explanation. What is meant by anchor means anchors are model agnostic explainability technique that provide rule-based high confidence explanation. This is what we have to keep it in mind. Next, what we are doing is anchor or set of feature condition. Whenever the conditions are true, the model prediction stays the same with very high probability. If a condition is satisfied means and the model prediction is high, that is above the threshold, then what it will do, it will stay in the particular instance and it will predict all the values irrespective. Now I am going to keep a hold here. So, okay, I will come here later. Uh, if condition 1 and condition 2 are satisfied, then prediction will always be particular class. Here we are going to fix the threshold. In explainable AI, the threshold is usually 0.95 for better understanding. Why 0.95 means there is no prescribed rules, but for better understanding, always by default, they are fixing 70% and 0.95 as a threshold while predicting certain values. So here what we are doing is, instead of telling feature A is important, this feature is only contributing, we are telling the feature is satisfying this value, satisfying this rule. That's why this feature is important. Now you can feel the difference. In the earlier line, what we have explained, this is high, value is high, so this is important. But here what we are telling, this feature is satisfying certain condition. Then, so that this feature is important. That is what the difference between Lime and anchor. Now you can understand. Okay. So first we are comparing two different conditions. And if it is not satisfying a particular threshold, then what we are adding one more condition suitably. Until the threshold limit get crossed, we are keep on adding the condition one by one. So what is the advantage? If we are having 200 labels, just like heart attack, glucose level, BP level, cholesterol level, these are called features. Here we are taking 100 features into consideration, means Lime and SHAP will take all the 100 features, and based on the contribution, we are telling that this factor is a highest contributor. But here what we are doing, instead of taking 200 features for analysis, we are taking one by one. First two features we are comparing. Precision is coming or not. That is, the prediction is attaining or not, threshold is crossed or not. If the two conditions are not satisfied, that is, income is greater than 80 and age is less than 60, these two conditions should satisfy. Then only it will predict. Otherwise, then it will check the threshold also. If the threshold is not met, then what it will do? It will add one more condition. Then it will once again check the threshold. If the threshold is attained means okay, not attained means next condition. Like that, it will add some rules. These rules are written by humans only. We are defining the rules. So on what basis the thresholds are attaining? These all the things are attained by human beings only. So why we can't fix this rule like this? So model begin to train as per a new defined rule. Once it got the threshold attained means what it will do, the model will anchor that, fix that rule for analyzing entire data. Analyzing entire data. This is called as anchors. Okay, just like what is anchor in a ship. If you throw a anchor in a particular point where it got a grip, if it find means it will fix so that the ship will not move here and there. It becomes stable. In the same manner, the model, the anchor will make the model high precise, that is stable and trustworthy. This is the concept. Okay. So now let us check. Slowly you can see here. So f of x be a black box model. We don't know. Here this x we are going to explain what is the thing, how the value is coming. We are going to explain. Here the space problem, please don't bother. A be a rule, not A be E. This is A be a rule. This A is a rule or anchor. So we are checking the precision is equal to probability of when two synthetic value and the black box model is equal to or equal along with the rule, then it is true. This is somewhat, if you are seeing very first time means you may get confused. What is this? I am not understanding. That is probability of getting black box model result and anchoring model result. Both should be same along with the rule. Rule should also get satisfied. If all the threes work together, then the precision will be high. That is true. This is the concept. Okay. Let us take this instant into a small breakup. The original input may be either patient or customer. One patient or one customer. Line model, no? One instance we are taking. Output of the black box model may be, in case of patient, disease is yes or no. In case of customer, loan is approved or rejected. A new artificial sample will be created by changing some features of X. This X features will be changed suitably so that you can get some artificial samples. That is called perturbation. Last thing we see. Perturbated samples. That means not real. The instances will lightly change and we are generating some synthetic values for analysis. If we change the value, what this model will do. If I change this value, what will be the model prediction? Like that, we itself changing lightly the values. So f of z is nothing but output of the sample. Same synthetic model we are presenting to the black box model, so that the output of the black box model and the synthetic model, what we are actually predicted, actual prediction plus synthetic prediction value will be more or less same along with condition. Then it is so up to these four steps, it is just a simple line. We are doing the same thing only, right? So first we are taking one instance, we are generating 100 samples, we are presenting to the black box model. After that, we are comparing with the original result. This is the lime concept. But apart from that, what we are doing, we are increasing, including one more additional thing that is called anchoring. We are including some rules here that will work along with the rules. This is the concept. So generate 1,000 samples. Keep only those where A of Z is equal to true. We are not checking entire thing. We are checking only A of Z is equal to true. Only true condition. If this condition satisfied means how many models are equal to the predicted results? How many samples are equal to the predicted results? We need to count. So here a numerical table is given. Here we are having 10 samples. Out of this, first 4 samples are yes, that is true, and remaining samples are no. So what is the beauty here? We are not considering all the 10 samples. We are considering only the 4 samples. Since condition is A of Z is equal to true. That means yes. And f of z is approved if both are equal. If true and approved both are equal, f of z is equal to f of x, both are along with the condition. If rule is satisfied, then what you are telling, you are telling it as true, that is yes. So similarly, yes approved, yes, yes approved, yes, yes rejected, no. This is the condition not satisfying, so it is giving the instant as false, that is nothing but no. Remaining Z5 to Z10 we are not considering since all the values are no here. So no is coming means it is false. We are not checking the false condition, that is violating the anchor condition. So we are not considering this. So we are putting not yes, no, we are not predicting. So we are putting a dash marks. Now you calculate all these things. How many samples? 4 samples. Out of these 3 samples are satisfied. 1 sample is not satisfied. Out of 4 samples, true is equal to 4, f of z is equal to f of x is equal to 3. So this condition is nothing but 3 divided by 4 probability. So 0.75. According to the initial concept, it should cross 0.95. Default threshold value should be 0.95 to validate the anchor. But here I am getting only 0.75. So it is not a strong anchor. So what I have to do, I need to make this anchor much stronger. So what I have to do, instead of, you can check here, income is equal to high only. I am considering only one condition, income is equal to high. Based on this formula, I am getting precision is equal to suppose 0.82. Then it is not a strong anchor. So what I am doing, I am adding one more condition. Credit score should be excellent. If I add this condition, 2 should be satisfied. Income should be high as well as credit score should be excellent. If both are satisfying means my precision will be how much? 0.96. So this is a good score, 0.95 crossed. So this anchor will be fixed. If income is equal to high and credit score is equal to excellent, then the model will gain 96% confidentiality in explaining the prediction. Loan approved. This is I am 96% confident that your loan get approved due to this condition. As since your income is high and credit score is also excellent. These are the things that will be taken into consideration. Now let us take a small Titanic data set, that is prediction is survival is equal to 1 and not survived is equal to 0. This is the small thing. 1 minute. Okay. Prediction is equal to 1 and survival is treated as 1 and not survived is treated as 0. Now, features used. What are the features here in the data set? I am having, there are so many features, but for explanation, I am considering only the top 5 features. That is sex, passenger, passenger class, age, and fare. So what model I am using means black box classifier. So according to the black box classifier, if I give sex is equal to female, passenger class is equal to 1, age is 29, fare is 85. Prediction, model prediction is, it is telling this data is under survived list. The passenger is under survived. In Titanic accident, The particular passenger of this prescribed values get are under the survived list. That is what we are calling. Okay. So these are all the theories already I explained. I don't want to repeat once again. Okay. So this also explained. Okay, this is called anchoring. What is meant by anchoring? These two values are fixed. Sex is equal to female and P class is equal to 1. Passenger class is equal to 1. Then survival is equal to yes. I am not considering all the 5 features. I am considering only first 2 features. One is sex and another one is passenger class. So sex and passenger class are fixed. I am fixing, I am not going to change. Other things like age, fare, these things I am going to vary. Now you can feel what is the difference. In Lime model, we are not fixing any instances, but in anchoring model, we are going to fix the candidates. Who are the fixed candidates? Who are the varying candidates that we are going to fix here. So fixed candidates are sex and passenger class, that is female and one. And attributed features only I am going to change. These features I am not going to change. This only I am going to change randomly. That is called attributed features. So synthetic passengers are generated around age and fare only, not with sex and passenger class. These two are female and one will be permanent. Age and fare will be randomly varied from instance to instance. Okay. Now, according to this, out of 200 generated samples, survived is 192, not survived is 8. So what is the precision? Just I will come to here. How 192, how 8, I will show you in an elaborate manner. Before that, you understand. Precision is nothing but 192 divided by total sample 200, 0.96. Threshold is crossed. So the anchor is accepted. So the model predicts survival with 96% confidence. This is holding of sample whenever the anchor holds. Okay. So anchor holds means if rules are satisfied. That is called holding of anchors. If rule satisfied means model will predict with 96% of accuracy. That's precision. So final anchor explanation is if the passenger is female and belongs to first class. If these two conditions are satisfied, then the model predicts survival with 96% confidence, regardless of age or fare variation. Whatever age or fare variation happens, it don't consider. It only fixed on 2 points since already the threshold is satisfied. So you don't consider these two parameters. So if female and first class means automatically 96% it will tell it is a survived list. Okay. So explanation is if based on if then rules, this is future contribution. What is this? Based on feature, how much the features are contributing, which factor is high, which feature is highly contributing, that will be taken into, that is the best player helps to predict a particular value. But here there is no such thing. Here if then rules. Depending on different conditions, the contributing will be selected. Precision is guaranteed due to if then rules. Here we cannot guarantee precision. Sometimes it may vary. So if you see the sharp waterfall, you can see how based on the highest nomination, we are telling that this may be, but we cannot explain why this cannot be. That precision we cannot guarantee. Interpretability is very high. Due to if-then rules, I can explain a instant. If this condition is satisfied, this. If it is not satisfied, that. Like that, I can interpret in a very high manner. This moderate level only I can explain. Coverage is low. We cannot employ this for very big data sets. Since different conditions, we cannot able to ensure. So smaller data set or in decision justifications, we can use this. But this can be employed for overall high level research outputs. For all these things, this can be employed. But the precision level guarantee. We are going to explain in that manner, but the precision is somewhat questionable only. So this is used for understanding the working of the model. This is for justifying the decision made by the model. These are the two things you have to keep it in mind. So now what I am going to do is I am going to work out with a simple numerical workout so that you can understand this easily. So same thing, these are all already you have seen. Now the feature value sex and female. Sex is female, passenger class is 1, age is 29, fare is 85. Model prediction is survived. How it is telling survived means we don't know since this is a black box model. Okay. Now I am going to fix the anchor condition. What are the two conditions we are going to fix? They are called anchors. So sex and P passenger class we are going to fix. So sex is equal to female and passenger class is equal to 1 throughout the analysis. Other features will change. So generate 10 attributed samples. Here you can check the condition. All are female anchors and passenger class always 1. These two will not change. But age and fare will change randomly. First will be 22, 80, 45, 150, 5, 120. Like that, this model is generating without disturbing the anchoring points. It is generating attributed samples for a particular instances. Okay. So model output, it is also generating randomly 1010 like that it is generating. This is based on the weights gained by the model as that of line, it is generating the results. Now count the predictions. How many survived you can count. Here two zeros are available. 0 means not survived, 1 means survived. So these two are not survived category. So out of 10, 2 are not survived. So 8 are survived. So survived 8, not survived 2. So what is the calculation? 8 divided by 10, 0.80. It is not crossing 0.95. So anchor is rejected. This anchor is not suitable for making a prediction. Next, what I have to strengthen the anchor. I need to make the anchor strong. For that purpose, what we have to do, I need to add one condition, add one more condition. Our rule only. We can add any rule and check. Now, what I am doing, now test only the valid samples. What condition I am writing, age should be less than 60. This is the sample, age less than 60. This condition is satisfied means consider. Otherwise, don't consider. Now you can see here age is 60 means this is okay, this is okay, this is okay. 4 is now 4 will not come into picture. 72 will not come into picture. That is 4, 6 and 10. These are not less than 60. So excluding 4, 6 and 10, we will get all the remaining models into consideration. You can see here 1, 2, 3, 4 will not come, 6 will not come, 10 will not come. So if I exclude means what happened? 4, 1 will come. That is yes, yes. This is also yes. This will not come. This is yes. This will not come. This is yes. This is also yes. This is also yes. This will not come. So all are yes. Model output yes means everything is 1. Not here. Based on this here. You can check model output. Everything is 1. 4 will not come into picture. 5 is 1. 6 will not come into picture. 7, 8, 9, 10 will not come into picture. So automatically all model outputs will be 1, 1, 1. So total how many samples? 7 samples. 3 are excluded, right? So 7 samples. So new precision will be 7 divided by 7, 1. 1 means 100% accuracy. Anchor accept. So what is the anchoring? New anchoring point. New anchoring point is if sex is old anchoring point is if sex is equal to female and P class is equal to 1. At that point, the anchor is not rejected. Now I include one more category. Sex is equal to female and P class is equal to 1 and age is less than 60. This is the anchoring point. Then the model predicts survival with 100% precision. Now, what I am doing, keep this condition in mind. Sex is equal to female, passenger class is equal to 1, and age greater than less than 60. Now I am going to the original sample. Sex is equal to female, passenger class is equal to 1, age is less than 60. So what the model prediction surveyed? These are the 3 points it will check for all original instance. So you can easily explain to the customer on what basis you are telling it is survived means the anchoring points are sex, passenger class, and age. So if I am writing the rule like this means, then automatically it is giving 100% surety that this is the survived list. So based on this only, we are predicting that the particular instance is under survived category. So these are called as anchoring. So the anchors are the rules. So the conditions are called as holding of anchors. If a particular condition are satisfied, then the anchor is said to be hold. If the conditions are not satisfied, then we need to train again and again until the threshold clauses 0.95. That is said to be anchor holding. Okay, so uh, provides 100% precision, but it only apply to the small data sets. We can compare small data sets and we can explain that in a local manner only, but it is not widely used. Globally, it is not applicable. Since we are having very big data set means it is not possible to explain. So it is to ensure the trustworthy local explanation. Local explanation becomes more precise. That for that purpose, they have introduced the concept called anchoring. This is how the anchoring concept is work. Hope you can understand what I am telling now. So this is the thing. You slowly practice this so that you can able to analyze what is meant by anchoring and how it is better than line. These all things you can explain in a very analytical manner. Okay. So in the next series, we will explain more concepts that are better than what are the further improvements, how to make explainability more perfect. These all things we will see in the next video series. Thank you for watching this video. I feel this is more understandable and effective. So in the next session, I will see you all. Until then, goodbye and greetings and wishes to all. Thank you, everybody.